Hi, my name is Renee Rizzo. This will be a teacher-facing video in which I will guide you through my adaptation of Physics Unit 5, Day 31 in the New York City Department of Education Teach Hub for students in alternate assessment settings. In this video, I will be using a PowerPoint presentation to demonstrate adaptations I made to the original lesson. Physics refraction. So the focus question is from the original lesson, and it's why does a pencil in water look broken? So, the reason why I chose to focus on this topic is if you search online, there are various examples of this experiment done at different age levels. So, it's an easy project to adapt for students at different levels developmentally. And there's many different directions that you can go with it. I would definitely recommend doing this hands-on with students so that they could experience it firsthand rather than just seeing a picture of it. And this is something that can either be done in person or remotely as well. So the standards, the next gen learning standard that I believe this lesson addresses is RST3. Analyze how and why scientific ideas and reasoning are developed and modified over the course of a text, source argument, etc. Analyze, evaluate the results and conclusions based on explanations in the text. And the NICE DLM essential element addressed, determine how individuals, ideas, or events change over the course of the text. The essential element linkage levels. Initial precursor. As a result of experience with a routine, the student is able to identify actions associated with the routine. Distal precursor can identify the order in which two events occur in an informational text. Proximal precursor can identify information that indicates the temporal order of ideas or events presented in an informational text. Target can determine how the individual's ideas, events, and other details change over the course of an informational text. Successor can identify how the author elaborates on the topic mentioned in the introduction and indicates how individuals, events, and ideas relate to and influence each other. So, the introduction model. When light passes at an angle between different media, the light does not travel in a straight line. The pencil in the glass of water is a normal pencil. The light that travels from the pencil through the liquid, through the glass, and into the air is bent differently than light from the portion of the pencil that is not in the liquid. And that has quotes around it because it's a direct quote from the original lesson. Your eye assumes that whether in water or not, the light moves in a straight line, but both halves of the pencil do not seem to line up with each other. Because of this, your eye thinks the pencil is broken, but it is not. So for this particular lesson, I decided to not go with the video that was included in the original lesson because it was a little too complex and technical for my students. So I instead chose to go with this video, Refraction of Light, Why Does a Pencil Look Bent in Water? And Awesome Kids Science. So I'm not going to show you the video, but I will give you a brief summary of what happens in the video. So video summary, a magic wand or pencil appears bent in water because of the refraction of light. So there's a little boy in the video who does magic tricks and he has a magic wand. So they demonstrate this first with the wand instead of a pencil, but then they also do demonstrate it with a pencil later in the video. This is part of a direct quote that was in the video. Refraction is the change in direction of light when it passes from one medium to another. The two media present in this case are air and water. When refracted rays reach our eyes trace them back as if they are straight lines. That's why the magic wand or pencil appear to be bent in water. So this is a multiple choice question that I developed based on the video. So what happens when light passes from air to water? A, it speeds up. B, it slows down or refracts. Or C, it stops completely. So the answer would be B, it slows down or refracts. And just a side note, the images included in this slide are based on the design feature in PowerPoint. So you can get design ideas when working from PowerPoint online. And I often like to use these ideas in my presentations. So, as you may know, that students in alternate assessment settings often do need image support to be able to comprehend the texts or to be able to give a good answer to a question. So I liked the images that were included there, and I enjoy the design feature in general when using PowerPoint in the Microsoft Office suite. So then I developed this other multiple choice question. Why does this happen? A, water is denser than air. B, air is denser than water. Or C, there is no difference in density between air and water. So this is a little summary of refraction of light in general. The speed of light changes in different media. The speed of light is slower in media that is denser. If light enters a media that is denser, it bends towards the normal line. If light enters a media that is less dense, it bends away from the normal line. The normal line refers to the line that is perpendicular to the surface of the media. And these little boxes of the different hues of green and blue were also a design idea that was embedded in PowerPoint that I thought gave a nice visual for this summary. So once again, the design feature within the PowerPoint in Microsoft Office suite is a really nice feature to play around with. So this was a teacher-facing video in which I guided you through my adaptation of Physics Unit 5, Day 31 in the New York City Department of Education Teach Hub for students in alternate assessment settings. In this video, I used a PowerPoint presentation to demonstrate adaptations I made to the original lesson. Thank you for watching.